Okay, welcome to 7.4, Vectors and the Dot Product. Okay, vectors and the dot product. Okay, so let's recall that if we're given a vector, v, so recall a given vector v with angle brackets x comma y. We have that. We have that x is the horizontal component, and we have that y is the vertical component. With an emphasis on the word component in each of these. Let me underline these. To understand, I really want you to understand the component here. Okay, so now let's consider two vectors u and v. So consider two vectors u and v, co-initial, with angle theta between them. Okay, so let's have a vector u, like so, something like that. Here's vector u, and I have vector v, co-initial with it, like so. And there's an angle theta between them. Well, we know that the length of any vector is its magnitude. So the length of vector u is the magnitude of u. So what I'd like to consider now is I'm going to project vector u down at a 90-degree angle to vector v, and I want to consider now the length of this side. Let's call it k. So I'm looking to find, I have an adjacent side and a hypotenuse. So I know that cosine, let me use green, cosine of any angle theta uses the adjacent side over the hypotenuse. So I know it's a quotient of adjacent side, in this case k, what the unknown, what we're looking for, and the hypotenuse is the magnitude of u. So cross multiplying, this gives us what? This gives us that k is just going to be the magnitude of u times cosine of theta. Okay, so that's what that length there is. So we can say that this is magnitude of u using trigonometry. This is a magnitude of u times cosine of theta. Okay, so what is this we just found? Let's define this. So definition. So the component of u onto v, that's what we're defining. The component of u onto v, denoted in lowercase c-o-m-p u, so the component of u onto v, so v is on the bottom, u is on top. U onto v is given by, or is the scalar, meaning real number, given by So the component of u onto v is going to be the magnitude of u times cosine of angle theta, where what is theta? Theta, where theta is the angle between u and v. Okay, so for example, find the component of vector u onto vector v in the following. Okay, so number one, let's say we have that vector u is 1, 1, and vector v is 0, 3. Okay, so let's note first. So x and y coordinate axes. So vector u is 1, 1. So it's along the main diagonal. Let me go ahead and put some tick marks in. So this is vector u, and vector v is 0, 3, so it's on the y-axis. This is vector v. So it should be evident that the angle theta between them is 45 degrees, or pi over 4, only because vector u is at 45 degrees, right? So what is the component of vector u onto vector v? Well, that's going to be the magnitude of u times cosine of the angle between them. Okay, so we get the magnitude of u, which is the hypotenuse, right? So it's the square root of 1 squared plus 1 squared. Pythagorean theorem. And what was our angle theta? It was pi over 4. Okay, so we get the square root of 2 for the magnitude of u, and cosine of pi over 4 is the square root of 2 over 2. So that reduces, and we get 1 as the real number, the scalar, which is a projection of u onto v. So if I go to a 90-degree angle, and it does look like the length, if I project u onto v, is indeed 1. Okay, so now let's do number 2. We'll just do a couple here. So number 2, what do we have for number 2? Let's see. We have that vector u is 2, 2 root 3. And we have that vector v is 3, 0. Okay, so let's note. There's a different way I could do this as opposed to drawing them. I know that, let's say phi is associated with vector u, so that's going to be inverse tangent of y over x, which for us is inverse tangent of 2 root 3. Maybe I should have given myself a bit more room. So that's going to be 2 root 3 over 2. So that's inverse tangent of root 3. Okay, so where is tangent? The quotient of sine over cosine. So sine needs to be root 3 over 2. Cosine would be 1/2. I'm in quadrant 1. So that's going to be at what angle? It's going to be at an angle of 60 degrees, or pi over 3. So that's the angle for u, right? And if I look at, let's call it, what should I use? Psi for vector v. Actually, I'll put this down a bit. So psi will be inverse tangent of y over x for vector v. So that's just going to be inverse tangent of 0 over 3, which is allowable. 0 in the numerator is just fine. So that's inverse tangent of 0. So where is sine 0? That's at 0. So psi is 0 radians. And that corresponds. So do you agree that theta, the difference, so theta, theta is going to be pi over 3 minus 0, which is just pi over 3. So theta is pi over 3. So now I can use that angle to evaluate the component of u onto phi. So the component of u onto vector phi is going to be the magnitude of u times cosine of the angle between them, cosine of theta. Make this equal sign in pink. So this is going to be, so the magnitude of u, that's going to be the square root of 2 squared plus 2 squared times 3. Remember, when you square a square root, you just get what's underneath. So this is cosine of pi over 3. Okay, so what do we have? We have how many 2 squareds? One of them plus 3 of them is 4 times 2 squared, 4 times 4. So the square root of 4 times 4 is 4. Cosine of pi over 3 is going to be 1/2. So I claim that this is 2. So if I were to project vector u onto vector v at a 90-degree angle, the length of that projection would be 2. Okay, so let's look at properties of the component. Pardon me. So properties. Of the component of u onto vector v. Okay, so I think we understand this setup, but maybe I should put this up here. Okay, so let's let u and v meet at an angle theta, right? And angle theta. So number 1, the component of u onto v, as we've stated, is the magnitude of u. The magnitude of u times cosine of that angle theta. Number 2, if theta is between 0 and pi over 2, then this implies that the component of u onto vector v is positive, greater than 0, because cosine theta is greater than 0. Or if theta is between pi over 2 and pi, this means that the component of u onto vector v is negative, less than 0, and that's because cosine of theta in that case will be negative. So number 3, if theta is equal to 0, this implies that the component of u onto vector v is just going to be the magnitude of u, and that's because cosine of 0 is 1, right? 0 radians or 0 degrees is 1. Number 4, if theta is pi over 2, this implies that the component of vector u onto vector v is 0, and that's because cosine of pi over 2 is 0. And last but not least, number 5, if theta is pi, this implies that the component of vector u onto vector v is going to be negative the magnitude of u, and that's because cosine of pi, or 180, is negative 1. Okay, I will see you guys in the next video.